So this is a lecture for, so far we talked about different kinds of product of science, and also you need to present your conclusion about the product of your research, such as description, explanation, etc., as an argument. Okay, but given that it's presented as an argument has a certain structure, we should talk about the structure of argument and how argument works. And in particular, this is important because scientific research is work to falsify or contradict existing beliefs. So let's talk about that. Okay, so we used an example. Okay, so let's think about an example. God does not exist because there is no evidence indicating that God exists thus far. In contrast, you can also make an argument that God exists because there is no evidence indicating that God does not exist thus far. Okay, compare these two different forms of argument. Okay, so you should realize that both of these arguments are not quite strong. The reason why is both of them say there is no evidence. So this means their argument of God does not exist or God exists are based on the absence of evidence. So therefore, it's actually a weak argument. However, I would like you to see that in number 2, there is no evidence indicating that God does not exist thus far. So I get to ask you a question. Is it possible to show that God does not exist? You may realize that it's impossible to show something, to prove that something doesn't exist, because it's always possible that if you use different kinds of method, you may be able to show that it's actually exists. So it may be just imperfect measurement and method. So number 2 is a weak argument. So keep that in your head. But you see argument like this. This drug is safe because we have an evidence that it's safe. Can you prove that it's actually safe? No, because even if the drug is safe, based on the current evidence, it's possible the next person who uses it may actually have a side effect. Okay, so it's impossible to exhaustively and forever say that a drug is safe. So instead, what we are saying is actually this drug is safe because we have no evidence that it's not. So when you think about that, this is exactly the same as an argument number 2 with the God argument. God exists because there is no evidence indicating that God does not exist. So why drug argument number 2 is scientifically acceptable argument, while the similar God argument number 1 is considered not acceptable? So let's move on to the next slide. So the reason is based on this assumption. That is, you can actually try to show that a drug is actually dangerous. How are you going to show it? You can actually exhaustively try to test that are there any side effect that's unwanted or dangerous that can happen even in just one person or one specific person, one particular kinds of people. So if you fail to find negative effect of the drug based on numerous research, you can say the drug is not dangerous so far. So that is the essence of scientific argument. Scientific argument doesn't say that this is basically true forever. Based on the current research, the best effort, this is the best things that we can say. That is the gist of essence of scientific argument. So your job as a researcher or student in science is not to believe in or support an existing literature or existing finding. As a researcher, you have an obligation to try to contradict or disprove the existing finding, because doing so would improve and further perfect our knowledge on science. So the essence of science, I'm going to use the boxing match analogy. So the best support for any existing theory or idea is obtained by subjecting the theory to the most rigorous challenge or test possible. This is akin to basically setting up the boxing match with the strongest possible challenger possible. Okay, so this is called principle of falsifying proposed by Karl Popper. Okay, so in sum, falsification in science, one does not work to prove that a theory is true. Instead, one works to falsify a theory. So this implies that science it assumes the kind of assumption that science may never reach the absolute truth, even though it gets ever closer and closer and closer. But we always assume that there are some imperfection in science. So therefore, you always try to challenge the existing belief. So, final question is, but at the same time, the science is considered to be very challenging. Why? Because the people have a natural bias to try to confirm what they believe instead of what they try to falsify or challenge themselves. So this leads to a tendency, right? Students find some theory or research finding that they like. So typically what students try to do is to kind of support the theory or plan an experiment that in support for the finding that you liked. But based on what we discussed, that's not what you should do. What you should do is the more you like the theory, basically the more skeptical you should be, because your challenge and scrutinizing, criticizing, and further subjecting to the better quality study is going to further improve the knowledge concerning that subject matter. But that's very difficult. So here's an example. Okay, so let's say that you believe that your boyfriend or girlfriend or wife or husband loves you. People tend to seek out the evidence in support of that, like giving flower, giving a ring. But according to the science, that's not what you should look for. What you should look for is you should look for evidence that challenges your own belief. Because if the person loves you, something should not happen. Okay? Like, for example, you look at basically, or the kind of, this is joking kind of example, but the thing is, the most clearest evidence that person loves you is you try to beat the person up and still says the person loves you. Because the thing is, that's the most obvious challenge. But however, of course, in the real life situation, that's actually is not reasonable, and that may actually destroy the love that your lover or boyfriend or girlfriend has to you. So therefore, it's not functional. So this actually tells what we actually do in science is not readily applicable to the real life situation, because what we are doing is an extremely kind of challenging situation that we set up to scrutinize the scientific knowledge. That's the only way in which we can ensure to obtain the very high quality scientific knowledge.